So quiz question number 1, we want to find C that satisfies the mean value theorem of this function on this interval. Now if you watch the videos, they explain that if you have some function on a closed interval from A to B, then there is a point inside here that they call C that has the same slope as the line connecting A to B. So if we connect A and B, whatever the slope is of this line, there's another point in here that has the same slope, and that's what the mean value theorem is. So let's actually use it to solve this quiz question. Okay, so the mean value theorem, it's the derivative of the function at C would equal, and if you notice what I'm writing, it's just the slope formula, right? So there's the mean value theorem. And we could, if I don't erase too much here, right, that was f of x equals e to x. We want the derivative at C, which is just another, I mean, it doesn't matter. You could leave it x. We could call this x. It makes no difference, just whatever you're comfortable with. But that's the theorem as you'd see it in a textbook, in other words. So we can just replace the x with the c in the function. So the derivative of e to the c is just e to the c. Or if you want to leave it e to the x, that's fine, and you'd be solving for x. No big deal. So now we're going to do the slope formula. So a is 0 and b is 1. So just plug those into the function. E to the first power is e, minus e to the 0 power is 1. And the denominator, just 1 minus 0. So what we have is e to the c would equal e minus 1. Anything over 1 is just itself. Now, how do I solve for c or x? Whatever variable you prefer. Well, remember that logarithm property. If I take the ln of both sides, and they cancel out. So c would equal, and we have it right there. And if you'll give me just a moment to take this off, I'll go ahead and work number 2 for you. And if you hear little footsteps in the background, that's the pet rabbit hopping around in the dining room area. So question number 2. Okay, question 2, we have this function. So there's the function over this interval 2, 4. Okay, so let's take the derivative of this function. So I notice I have a single term in the denominator, so I can split that up or do the quotient rule, either way. So split it up. That's 1. So now if I take the derivative, 0 plus 2 over x squared, all right? That makes sense? Just take that part and rewrite it as that, and then I can do the power rule. I'll bring that exponent to the front. There's your positive sign. Take 1 away, and when you put that in the denominator, you get the positive 2. Okay, so there's the derivative, 2 over x squared. Let me go ahead and take that off. So we got 2 over x squared would equal. Now this side we're going to do the slope formula. So we're going to plug in a 4 for x. So that's 4 minus 2 over 4. Minus, plug in the 2. Well, here's something good. When I plug in the 2, 2 minus 2 is 0. So, I mean, I really don't care anything else. That whole part is just 0. Over, don't forget this part, over 4 minus 2, which is 2. Okay, so we have 4 minus 2, 2 over 4. We have 1/2 over 2. So dividing by that 2 would mean I'd have to multiply by the reciprocal. Let me just clean that up. Got ahead of myself. That's 1/4. So if I solve this for x or C, if you want to use the C, that's fine too. So we just do some cross multiplication. And take the square root of both sides. We get the square root of 8. And if you break down the square root of 8, you'll get the right choice for question number 2.